Hello friends, today we will be talking about the topic of projection in the computer graphics. It is a very important topic so far as your examination is concerned and so far as the practical aspect of the subject is concerned. Actually, we had already described in various sessions that the goal of computer graphics is to provide you the realism, and whereas the projection will distort the concept of realism, which will be clear to you just after few more things which are to be discussed right now. Now actually, what do you mean by projection? The projection is a concept of resolving n dimensions into n-1 dimensions. Now purposefully I have used the concept of n dimensions because most of the persons say that there are only 3 dimensions, or there are at the most 4 dimensions. 3 dimensions are for space and the 4th dimension is for time. But I would like to say that there are n dimensions, and please correct this misconception, because from a point it is not necessary that only 3 lines will pass, as it is in the case of your normal Cartesian coordinate system. Through a point n number of lines can pass, and each line is contributing it to a dimension. So there is a possibility of n dimensional space, but because our eyes are sensitive to only 3 dimensions, so we are restricting to the realism up to the limit of 3 dimension, and the 4th dimension is considered as a time. So what do you mean by projection? Say take a 2-dimension system and let OA be a line where A is a point at a distance r from origin O. So that means this point O is x units away on x-axis and y units away on y-axis. So this point will be having the coordinates x, y. But by having the projection, that means by incorporating the theta component in this direction, along x direction or along y direction, we could have the value of x or the corresponding y. How? Which is already discussed in the case of transformation, because we know that perpendicular, hypotenuse, base, and you will find that it is sine theta, it is cos theta, and it is tan theta. So by substituting the same, what is a perpendicular over here? It is y, and your base is x. So you will have y upon your hypotenuse is r, so y upon r is equal to sine theta. Similarly, x upon r is equal to cos theta. So you will find that y is equal to r sine theta and x is equal to r cos theta. So x is equal to r cos theta, this unit is the projection of this point, of this line OA along x-axis. So what is happening, that we are having this point will be nothing but x 0, and this point will be nothing but 0 y, where x is r cos theta 0. So what we are doing is that a 2-dimensional system is now resolved into a single dimension, which is only r cos theta, or which is only r sin theta. So 2D is resolved into 1D. So let me make it more clear that if you are having a 3-dimension system, okay, say you are having a ball and you are taking the picture of that ball, then what will be the picture of that ball? The picture of the ball will be a circle. Yeah, agreed? And then that means by taking projection, this is a 3-dimension sphere. So this is a sphere or a ball, and when you take the projection, when you take the photograph of this projection, what happens, that you are simply having a circle. But that means there is a loss of information. Over here you was having the information about the x, y and z component. But while having its projection on a plane, you are having only x and y, and one component is lost. So that means transforming a 3D to a 2D or a 2D to a 1D, there is a loss of information. Then how you compensate this information? The compensation of this information is done by providing some shading effects. Say you consider that light is coming from this, then how will you incorporate that some shade? That you incorporate some shades, and you will show that yes, some shade is there. And by providing these lighting effects, you are giving the effect that even though it is projected as a circle, but in fact it is a sphere. And that's how, that is by incorporating the concept of shades, you are incorporating the concept of realism. And that's why the concept of shading arises. We will study in the successive sessions about the various shading effects. Likewise, your ground shading, grunt shading, Phong shading, and constant shading, which is depending upon the intensity interpolation and your normal interpolation. And again, I want to emphasize that interpolation is a very important technique, and this is also discussed in your MCSE 004. So by using those techniques of shading, we are giving you the flavor that this is a three-dimensional object. So one example I would like to quote also, that our eyes, the word is three dimensions, and when we are viewing something, our eye is a plane which is a two dimension. So the rays of light are coming and they are making an image on our retina, and that means there is loss of information. This loss of information due to projection is known as rendering. But what we are doing, we are using some more information which is coming along with the light, and use that information to find that what is the size, how far an object is from us, how close it is from us, whether it is a two-dimensional object or it is a three-dimensional object, or whatever information about the same is. So projection is very important. So let's discuss what are the major components required to have projection. Actually, say this is the center of projection, say this is your viewer, this is a plane of projection, and this is say some object, say it is a sphere. So this person is viewing the sphere. So what happens, that the projection of the sphere will be observed, or the image of likewise in the case of, you might have produced a pinhole camera in your childhood, where the 3D world is projected on a simple paper sheet, and the projection will be simply a circle. That is sphere. So this is an object which is quite important requirement for having projection. This is center of projection. And this is viewport. Now these are the rays of light which are producing the image on this plane of projection, which is a viewport, and these rays of light are nothing but projectors. These are known as projectors. So far as the mathematics, now this is projection. You are resolving a 3D system on a plane that is a 2D system, so there is loss of information. This loss of information is compensated by using various properties, shadings and your lighting and all those things. So, but three important things are center of projection, plane of projection, object and projector. Now one thing, so far so as to understand the mathematics behind the same, because you are supposed to write the programs to have the projection, the mathematics is that this is a line from the center of projection to the object, and this point is a point of intersection of this plane of projection and this projector. So locus of such point यार एसीटोन तो है नहीं, अब ये क्या करें हम, पानी भी नहीं है. So I would like to say that three major components which are required to have projection are your center of object projection, that is the observer, the position of the object, the viewport, and the projectors. Now in order to understand the mathematical aspect of projection, consider the point of intersection of viewport and the projectors, because the image produced is nothing but the locus of all the points which are produced by the intersection of the projectors and the viewport, and our motto is to find so as to find the image is to find these points of intersection. So how we can find these point of intersection? In order to find these point of intersection, we are supposed to use the parametric equation of line, and which is discussed various times, but let me give you a brief introduction. Say if P and Q are 2 points, if P and Q are 2 points, then you generally create the line by using the equation y is equal to mx plus c, but this is not a parametric part because we are not taking care of the parameter to produce this line. So for the parametric version of this line generation is concerned, we should use P plus T Q minus P. Now this is the parametric equation because the entire generation, pointwise generation of the line depends upon the parameter T. How it is dependent? When T is equal to 0, we can have P plus 0 into Q minus P, that is only point P is available. When T is equal to 1, P plus 1 into Q minus P, so P cancels out and only point Q is available. That means if T varies from 0 to 1, if T varies from 0 to 1 is Bolo. So for the value of t which lies in between 0 and 1, we are capable to produce entire series of points which are responsible for generation of line from point P to Q. Now what is the relevance of this parametric equation of line with this case of projection? Because this is a line from, say, center of projection I is E and say your object is P. So we are producing a line from E to P, that is E plus T, P minus E. And for the point of intersection, we are supposed to find what is the value of t. If we are capable to find the value of t with this intersection, with this viewport, then the problem is solved. For all those values of t, we are capable to find the image, locus of all those points. So one important observation after this is that in this case, what you are observing is that the projectors are angular, but this may not be the scene in every case. If the object is moving far, so you just see that what is happening, the projectors are simply coming close to one another. That means if the object goes to infinity, the projectors will become parallel to one another, and when that means in that case we won't have the angular projection. That means when the projectors are angular, and this projection is known as perspective projection. When object goes to infinity, the projectors become parallel, and in that very instance of time we will be having the parallel projection and not the perspective projection. So because now the point P is at infinity, so since P is at infinity, what do you think this parametric equation of line will hold or not? No, it will not hold, because our point P is at infinity, so whatever thing is added to the infinity will remain infinity. So how can we find this point of intersection in between the plane and the projector? In order to find this point of intersection, in order to produce this image, we are supposed to modify this parametric equation of line, and this parametric equation of line for parallel projection modifies to E plus T D, where D is the direction vector, direction in which the object is there, or direction in which the viewer is viewing the object. So this is an important point, that projection is classified into two: the perspective projection and your parallel projection. Further classification says that parallel projection is classified, that means over here the projectors are angular, over here the projectors are parallel. Again in the parallel projection we are having two types of projection. One is known as oblique projection and other is known as orthographic projection. What do you mean by oblique projection and what do you mean by orthographic projection? Let's see to it. Say this is your plane of projection. The projectors are parallel to one another, but they are not parallel to the plane of projection. One more possibility is that the projectors are parallel to one another, but they are perpendicular to the plane of projection. When projectors are parallel to one another, but they are not perpendicular to the plane of projection, then the projection received is nothing but your oblique projection. When projectors are parallel to one another, but they are perpendicular to the plane of projection, the projection received is orthographic projection. Orthographic projection is further categorized into axonometric projection, isometric projection, dimetric and trimetric. What we mean by axonometric, isometric and trimetric projection, let me give you just brief introduction. We will discuss them in detail in my successive things. Now, the axonometric projection says that it is a projection in which all three faces of an object are visible at an instance. Let me show you by an example. Say this is the box. In this box, all three directions x, y and z are visible at this instance. Such a projection is known as axonometric projection. Now, in the isometric projection, diametric and trimetric projection, we take care of the concept of foreshortening factor. What is foreshortening factor? Foreshortening factor is the factor by which the image is reduced, by which the object image is produced. That means it is the height of image or the size of image over size of object. And it is the factor which decides, say we are having various maps and we are having the scaling factor in every map that 1 centimeter or 1 millimeter is equal to so many kilometers. Because from the satellite we are taking the image of Earth, and on, in the image we are having the distance in between Delhi and Bombay, say of 2 millimeters, but it is hundreds of kilometers. So we are supposed to decide the factor by which the image is reduced, and that factor is known as the foreshortening factor. So if the foreshortening factor along x direction, y direction and z direction is same, then the projection produced is known as isometric projection. Fx is equal to Fy is equal to Fz. Similarly, in diametric projection, what the parameter is that the foreshortening factor is same in two directions but not same in third. That means Fx is equal to Fy but not equal to Fz, and similarly other combination. And in the trimetric projection, in none of the directions the foreshortening factor is equal. So this is the phenomena which is used to classify the projection. So before going into the details of these orthographic projection, oblique projection and these projection, let's try to solve some numericals and get a flavor that how we are supposed to attempt the problem in examinations. So in order to understand, consider the case of point projection. So let me solve a numerical for you. Say this is a system in which the plane is there, the observer is at say 0, 0 minus d position. Should I? So what is to be determined is the point of intersection of this line and the plane. Now, what is the plane given to you? On every point lying on this plane, you will find, say this is x and this is z. Then what you will find that this is a xy plane because lying in xy region, and every point is having the component x, y, 0. So it is a z is equal to 0 plane because every where the z component is 0. So it is not always there that the type of plane is given to you. For a matter of chance, for the sake of simplicity, I had discussed that the plane given to you is z is equal to 0 plane. Now by using the parametric equation of line, that is E plus T P minus E, we can find this point of intersection. Let's see how. The point E is given to you as 0, 0 minus D. T is the factor to be found. P is the generalized point in the space, which is x, y, z minus 0, 0 minus D. So solving the same, you will have 0, 0 minus D plus T x, y, z plus D. And again solving the same, you will have Tx, comma Ty, comma Tz plus D minus D. So we are supposed to find the value of t for which this point should lie on the plane. That means this point should satisfy the equation of plane. Now what is the equation of plane? The plane is z is equal to 0 plane. So the z component of this point should be 0. So by substituting the z component as 0, we can have Tz plus D minus D equal to 0. Hence T is equal to D over Z plus D. That means for this value of T, we can obtain this point. So by substituting this value of T in this point, we can find what the value of this point P dash is. The point will be D over Z plus D x, comma dy over Z plus D, and then Tz plus D, that means D over Z plus D into Z plus D minus D. So Z plus D cancels out and this turn out to be 0, and which is very true. So we will be having dx over Z plus D, dy over Z plus D and 0. So generally what is asked, that determine the projection matrix. So in order to determine the projection matrix, let's transform, because this is your Euclidean system, let's transform this Euclidean system into the homogeneous system. In homogeneous system, factor of homogeneity is also involved. So the homogeneous system, we have dx over Z plus D, dy over Z plus D, 0 and 1. So what is the factor of homogeneity? Can be obtained 1 plus Z by D, 1 plus Z by D, 0 and 1. So this is the factor of homogeneity. So you can simply say that this is x, y, 0, 1 plus Z by D. So can you write this in the terms of matrix? Let me write it for you. So x, y, 0, 1 plus Z by D is the data. So let's write it x, y, z and 1. So matrix will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0 and 0, 0, 1 by D, 1. So let's check it out. This into this plus this into this plus this into this plus this into this, x, yes, x. This into this plus this into this plus this into this plus this into this, y, y. Entire column is 0, so 0. This into this 0, this into this 0 plus this into this, Z by D plus this into this, so 1 plus Z by D. So this is the matrix which is your projection matrix. As it is said that, and this question is solved, that that the plane equation of plane is it is not like that it is always given to you that it is equal to z is equal to 0 plane or z is equal to d plane. Now what will be z is equal to d plane? Say I take it z is equal to d plane. So on z direction, say I take d places, say I reach over here, then every point on the plane which passes through this point d, the value should be d, the z component should be d. So what should be the value? This point, this is z is equal to d plane, because this is a xy plane which passes through the point where z is equal to d. So the point will be x, y, d. So if somebody asks you find the projection of a point x, y, z where the center of projection is 0, 0 minus d on z is equal to d plane, then you simply perform this exercise only, but instead of having z is equal to 0, you evaluate the parametric equation z component equal to d, and you will have the solution. So one more exercise I am going to discuss right now, that how to find the equation of plane, because sometimes it is not given to you. Then in that situation, how will you find that equation of plane? So what I would like to say that by performing these steps, you can have perspective projection of a point. And since line is a sequence of points, so same concept can be applied to have perspective projection of a line. And at the same time, I would like to say that in the parallel projection, the parametric equation is modified to a plus dd, and the same applied concept can be used in that sense. And this I would like to say about the projection. Thank you. सारा तो लाइट में चला गया.